Okay. We left off in the last lecture around this area about creating a method that uses multiple parameters. In the example that you have on the board, you'll see that it's calculate gross, which is double hours, and double is what type of variable? Decimal, and double rate. And inside the method, they're assigning the hours and the rate to a variable called gross, which is the gross amount. Now, another way you could actually do this assignment is say double gross equals hours and rate. You don't have to, you always don't have to spell out the assignment like it is here. You could make it more succinct. And then they're spitting out the value. System out print line, hours plus string literal, hours, space, hours at, $. Okay. Notice that the string literals, they always have the plus sign for concatenating integers to strings. All right. If, for example, if you try to put two numbers together and put a concatenation symbol, and you don't make it where one of them is first thought to be a string, it will actually do the calculation in the print line statement and spit it out. So you have to think about how the first value is treated. In regular operations, it's left to right. So if there was a plus, if there was a quote with a space, quote, plus hours, it would do that concatenation first and convert an hour then to a string. And then when you did another number after it, it would instead of being the addition of those two numbers, it would be another concatenation of a string. All right, let's go on a little bit. So you got your return statement. Things to remember about your return statement. This causes the value to be sent from the called method back to the calling method. And your return type, it can be any type of data. It could be primitives. It could be class types. If you create a custom class like car or pizza, or you can return that as an object. Okay. It can return void. The method's type is the method's return type, and they must match. They must match up. So, for example, in this example here, the method's return type is double, and this down here must be a double that's returned. If it isn't, you'll get a compile time error. It won't even compile. Okay. Let's think about unreachable statements. Later on in the class, you're going to get, later on in this course, you're going to get to some topics like the switch case statement, or if-else statements, and you can put a return in the logic of those if-else statements. And the return will exit out and not allow any other code to be called later on, because it keeps it from executing. However, if you do not have a return statement inside of a switch case type statement or an if-else statement, and you try to put code underneath the return, you're going to get a compile time error because it's not in a code block that the compiler will recognize. And in a few moments, I'll give some examples of that, why it won't compile, and in cases where it could compile. All right, so any method might call any other number of methods. We typically call this a black box type of logic. We don't know what it does, you're calling it, and it just does something. You don't need to know what it does, in fact. All you care about is that the result is what it says it is. In this scenario here, you have a couple of methods calling other methods. Now, this is a great example of how a method is used to encapsulate functionality for reuse. Each of these methods here that we see, they're called for a single purpose. A single purpose, and it's what they're designed for. It makes them great for reusability. So think about calculate gross. Calculate gross has one purpose and one purpose only. It's to calculate the gross. The calculate withholdings. It's very simple. It has one purpose and one purpose only. And the way that these are written, that code then it can be reused anywhere in the class or by other classes. It's a great way to keep yourself from repeating yourself all the time. If you find yourself repeating yourself in the code, you might need to take a step back and go, okay, can I make this a method? Because I keep asking it to do the same things over and over again. Those are great places for methods. All right, looking at them closer, you can see they return a value, and we can infer what type of value they are because what they're the values that are declared here. For example, calculate hours is being assigned to a gross, and gross is a what? It's a double. And so we're pretty sure here that calculate gross, the return type is a double. Calculate withholdings, it assigns to the withholding variable, and withholding is a double. And so we're pretty sure that calculate withholdings has a return type of a double. All right, so then we get down to some simple mathematics here. And always remember that you want to put the larger number on the left, because if you don't, you won't end up with a salary, I guess. You'll end up owing your company. And then, of course, we see at the bottom that the value being returned, net, is a double, and of course it matches the declaration of the method up here. Now, this is something that you could do. You don't necessarily have to put net. You could put the return right here on this line without the net variable, and it will assign the the subtraction, the product, the sum of that, it'll assign it directly to the return and spit it out. And you're thinking about later on with repeatability, are you repeating the same processes over and over again? The only time that the net variable is needed is if you're ever going to use it again. And if you don't ever need to use it again, then you don't need to declare it. In this instance, you can just say return gross withholdings. All right. Classes. All right. Guys, this is going to get confusing, so I really want you to tune in your antennas and listen closely here. The language here that we use for classes is often referred to as a is-a relationship. Is, in English, is a word that means equivalent. So, equivalent types would be, this is a class room, right? So this meaning this room we're in, this is a classroom. That's an equivalent statement. Is a relationships are equivalent statements. So here's the key. Every object is a member of a class. An object is a concrete example of a class. Chris is a concrete example of a human, right? He is one version of humanity. This is an example of a desk, although it's a flimsy desk, right? The zoo's shark is a example of a fish, right? A shrew is an example of a rodent, right? There's an is-a relationship there. That's very important when we talk about Java and object-oriented programming. If you can wrap your mind around that concept, everything else will begin to make sense, because then you can model real-life objects in code. You can think about things as, well, no, that's not a is-a relationship. That's something else. All right, so instantiation. I've used that word a lot, and I'm glad I used it early on for you guys. Shark is an instantiation of fish. So if you think about a real-life shark, how is it an instantiation of a fish? We're talking about types. And if I was to write this on the board in Java code, I would say fish, the variable shark, equals new fish. Shark is now an instantiation of the fish. Does that make sense? So classes are really designed about reusability. I mean, that's the whole purpose of coding. You want it to be reusable. You want to be able to use it again. Otherwise, why code anyways? We'd all be back with chisels and hammering rocks trying to pass information to each other. All right, methods are often called upon to return the piece of information to the source that requests them. All right, so methods are encapsulated in these classes off of these objects, and we call upon those methods to get details about the object. So if we think about, for example, the pizza class that we developed the other day, and the interface was the pot pie, right? Or no, the pie. Pie was the interface, and pizza became an implementation. So did pot pie. So you can think about things that are alike and attributes that they share. All right, so the class client or the class user, an application or a class that instantiates an object of another pre-written class. So this is straight out of the textbook. A class client is an application or a class that instantiates an object from another pre-written class, or a class user. All right. Creating a class. You guys have already done some of this. You've seen it with the car class in the code I sent you. You saw it with the pizza class. You assign a name to a class. You determine what type of data and methods are going to be a part of the class. You create the class header with the three parts. Now, the public is the optional access modifier. The keyword class is required if you're going to create a class, because you're telling it what type of object this is going to be. And then any legal identifier for that class. Always remember, the rule here for your classes is to make them uppercase, the first letter. It's always the rule. Because anyone then looking at the class later will go, oh yeah, it's a class because it's uppercase. All right, so the public class is accessible by all objects. All right, let's look at the employee example. Here we have an employee, and it has an attribute. It has an attribute called employee number, right? Let's think about this for a moment. If we wanted to expand the employee class, what is a typical attribute that every employee has? Right? That's the employee number. But what's another attribute? Okay, they could have a social security number. So you would declare, in this case, private string. You all know why I'd do a string instead of an int? You could do an int, but usually we put these dashes, right? What's another attribute? Name. Very good. Now, here on this island, we have multiple names. My son, his name is Michael Dewey Tudela Assumption Rogers Jr. It's a lot. But we did it because of Article 12 here on the island. You know what Article 12 is. It's the land issue. It makes it easier when he goes later on. But a person can have multiple names. And so when we went and tried to get his birth certificate done, they're just not equipped for more than 5 names in a person's name. So we had to hyphenate things. So when you're thinking about modeling real reality, that's a misnomer, isn't it? You're modeling things in reality. You got to think about what are the attributes? What would I want to model that would make it more expressive? So you typically have a first name, a middle name, a second middle name, because they do that now in all U.S. Now they actually have a third one, I believe, for Social Security office. Then they have the last name or the surname, and then they have the suffix, which is either first, second, third, junior, senior, right? All right. So we have name, but what is another common attribute we might want to add? Gender, yeah. Age, date of birth. How about, there you go, department. Yeah. Do they work in the business department? Do they work in HR? Do they work in, what's that? Nursing. There you go. It's a hospital. All right. So you want to model reality. That's the idea. All right. Let's go on. Classes, all classes extend from one primary class. Do y'all know what class that is? Unless you're a primitive. Primitives are remember the int, long, all lower, small case, right? But if you're like a class, a real class, all classes, even classes you create, just by virtue of being in Java, they all extend by default from, does anyone know? This is where the toString method comes from sometimes. What's that? Oh. They extend from the object class. Okay? So the data fields that you extend from, though the data fields in the parent class are actually available from the object you extend from. So you could write some code and say, you know what, I'm going to use Mr. Rogers' code for that pizza, and I'm going to extend from it, and I'm going to create my own version of the pizza class. You could say public class Domino's Pizza extends from pizza. And you would get all of the methods, all of the attributes, all of the member variables, all for free because you extend from it, right? You would get the instance variables. If they're not private, then you could see them. Okay? So non-static fields are given to these objects. Non-static fields, this is important because I brought this up last time. If a method is static, it's treated on the class level. If the method is not static, it's treated as an instance method, meaning you have to instantiate the class as an object in order to access that method. All right. So private access for fields. No other classes can access the field's return value. If it's private, can't access it. Only methods of the same class are allowed to use private variables. What that means is in my pizza class, I declare a private sauce, private string sauce. If you extend from my pizza class, you can't see that sauce because it's private. However, the only class that can see the sauce is the class that it resides in because it's private. Okay? All right, this is called information hiding. Information hiding is a topic you're going to hear and see over and over again. 99 times out of 10, 99 times out of 100, All classes are public. All right. I went in for a interview one time. This was about 4 years ago, and I just totally, my mind went blank. And they said, "Can you give me an example of a mutator method?" I went, "A what?" All right. So what does mutate mean? Change. So anything that changes a value is a mutator method. Anything that accesses is called an accessor. Those are the ones that retrieve. So it's very common once you create a private member variable that you want to control access to that private member variable. And so you create a getter, which is an accessor, and you create a setter, which is a mutator. Now these are very important concepts, mutator and accessor. All right, so non-static methods. We just touched it. Let's talk about it again. Non-static methods are instance methods. They belong to objects. They're an instance of that object. Okay. Typically, you declare non-static data fields as well. A static class variable is not an instance variable. That's important. Yeah. All right, so here's a quick table. I recommend to come back to this table quite a bit and look at this and kind of study it. The bottom there says static class variables are not instance variables. Right? That's on the static side. Non-static, these are instance fields or methods. These are non-static. Here's something interesting about this. And you may be tempted to do this. You may be saying, "Oh, well, Mr. Rogers, it's better memory management in my application to make all of my methods static and because it's only used one time in memory." That's true. You have a class and all of its methods are static. It doesn't matter if you declare that class 100 times through your program. It's only used, there's only one reference in memory because it's static. It's unchanging. Whereas if you you have a non-static method, if you declare that class 100 times, there are 100 instances of that class declared in memory. Now, these are some concepts that are kind of important to think about because Java has a garbage collector that's built in, and as objects move out of scope, the garbage collector comes along and says, it's a custom algorithm. No one really knows how it works because it's up to the garbage collector. Goes through and it picks up things that are out of scope and it just gobbles them up and then releases that physical memory again for the computer to use. But it takes time. So non-static methods, the garbage collector has to come along and gobble them up. All right. This is a very hard screen to see. Can you all see that very well? It's very tiny. What it has on this screen, you have a class called test class, and inside of it you have a object being created, instantiated, called object from the my class. It's very small. If you got it on your own screen, you're going to have to really kind of almost put your forehead to the monitor to see it. So you have my class object equals new my class, and then you have object dot put non stat method. See, I can't even see it. Yeah. Pub non-static method is the name of the method, right? And what they're trying to demonstrate is that is a legal, meaning yes, it can be done. It's legal because it's an instance method. The one below it, object pub state method. This one, if it really is a static method, you don't have to, you can still access it that way because all static classes are still available from objects, but you don't necessarily have to do it that way. The one right below it, myClass.pubStat method. That's legal as well. You can do it that way. All right, now let's look at the other one. Test class doesn't have the access to the private method. So here, myClass.privateStat method. Well, remember, if it's private, you can't see it, even if it's static. So it kind of begs the question, does it make sense to have a static method that's private? Sometimes it doesn't make sense to do that, unless it's only going to be used by another method in the class. And a static method can only call other static methods. Otherwise, you have to instantiate the method as an object. All right. So then you have object.privateStat method. Well, you can't do that either. Can't call a private method from it, from an object that's instantiated. All right. I recommend you all come back to this and actually test this on your own code. Try to write some of these out and test it and watch the compiler complain or the fact that you can't get to it. Some of you are like, I don't want to see the compiler complain. That's hard stuff. But it's actually the best way to learn how to code is to read what those error messages are. Okay. All right, so let's look at this one. Here we have public class employee, and it has a private member variable called what? What does it have? What's the private member variable? Employee number. And so then we have an accessor method and a mutator method. What is the mutator method here? Set employee number. And you can see that it's passing in an int. It's assigning it to the value imp number. And the accessor method is what? Yeah, get employee number. It has a return type, and it's saying to get it. The reason why you use mutators and accessors is you're trying to control how that value is accessed. You may be thinking, well, I really don't, can I just make all of my member variables public? You could, but then you don't know how your user is going to be using that data. And you open yourself up for, they could contaminate your data that way. It's better you control access to the data, how it's used, especially if someone else is going to be using your code. You write the code, give it to them, and you want to control access to it. All right, so organizing your classes. Has anyone ever, I've talked to you all before about spaghetti code, right? Back in the HTML class where you have CSS in some places and HTML and JavaScript all mixed in together, and it's, don't do that, right? So even here, you want to keep your class structure very organized. You want to keep really all of your data fields at the top and all of your constants up above your data fields. Then your constructors underneath that, and then you have your methods, whether they be accessory methods or mutator methods, all below that. Okay, and here's a good example. You can see that logically we're sorting all the data variables. We're keeping everything to the top, just inside the curly braces. And after the last field declaration, that's where we're going to put our member variables. This also makes it easier to find things. Because if you have a class that has maybe 50, 60 lines of code, your eyes are going to get to hurting. You're like, where did I put that variable at? Right? You organize your code that way. And you can see here, this is another example of doing it like that. Okay. Again, they have all of their their accessory and mutator methods grouped together. So employee last name is grouped with employee last name, or first name setter with the first name getter. All right, let's go on. Okay, we've done this before many times. This is how you declare your classes, how you instantiate objects. So employee, some employee, or you could say employee, some employee equals new employee. The new operator, that new keyword, you always have to have it there in order to create the object. All right, we talked a little bit about this last class concerning default constructors that are provided when you don't have any that are created. Okay, so the constructor method is always there if you don't create it, but if you do create it, you're overriding the default, and so you have to make a design decision how you want to create your classes, whether you want to use the one with all your parameters or if you want to use just the one without. All right. Your method calls, so you have the object dot the method. That's how you call them. All right, we use a dot syntax in Java. And you see another example here. You have the employee class is instantiating a clerk object. We're also instantiating a driver object. And for the clerk, we say clerk dot set employee number, and we pass in the number. Driver dot set employee number. And then we're accessing it through the getters that are provided. Clerk dot get employee number and so forth. All right. Data hiding using encapsulation. We've talked about this before. Data fields are usually private. We don't make them public. Client applications, we provide some type of interface. And again, you got your setter and getter methods. Okay. The get method is your accessor. Your set method is your mutator. We'll go on here. Now, your constructor is a class level method. It creates something for you. It's returning something for you. So when you're calling it, you're actually calling a method named employee, and it's generating the object for you. And so we say new employee, and it generates that object. And we've talked about default constructors too quite a bit. All right. Any questions about default constructors though? All right, we'll go on here. All right, so this is important. Your primitive values. If your constructor, your default constructor, does not set the value, your primitive values are automatically set. If they're numerics, they're set to 0. Meaning, if it's an integer, a byte, a long, a short, a double, a float, a bit, all of them are set to 0 when the constructor creates the object. This is your private member variables in the class. So everything is initialized in the class, is what I'm trying to tell you. All of them are initialized. If it's an object, it initializes the object to null. So if you have a private member variable in your class that's actually from another class you created, that class object, when the constructor creates the overall class, it initializes it to null. If you have a char field, it is initialized to this unreadable Unicode statement here. It's in quotes, right? Single quotes for chars. If it's a Boolean, it's automatically set to false. Okay? All right. Your constructor method must be the same as your class name. So if you're, I've seen this in some homework assignments. I've noticed some of you guys have done this a couple of times. You call your Java file assignment, I think it was assignment 4, I saw this a lot, assignment4.java. You open it up, and inside it says public class number demo, and then it won't compile because the class name has to be the same name as the file name. And it's the same way for the constructor. The constructor must match the class name. Okay. And constructors cannot have a return type. So you can't put a return inside of a constructor. It's implicit that it returns the object of the class itself. All right. The other thing was public access modifier. You can have a private, and all that means is that you can instantiate the class. Now, there are reasons why we would do that, and that means that you have to instantiate the class through another method from within the class. But it's a good rule of thumb to make sure that your constructors are public. If they're private, you won't be able to instantiate it from outside. All right. So here we have a constructor. The constructor here is public employee. And inside of it, we're doing something special. We're assigning a value. This is a good way if you want to enforce certain values to be automatically initialized to a specified value. You can do that right in your constructor. Okay. Classes you create. This is important for you to know if you're going to go take a Java certification exam. When you leave here and you get out of this class and you try to go apply for a job somewhere and you tell them, oh, I took a Java class. The employer is going to say, that's interesting. Next. They're going to want you to have a certification. And a certification is a piece of paperwork that's issued by a certifying body that says, yes, they do know what they're talking about. I took 3 Java classes over a couple of years. And I love programming in Java. And then people would ask me, do you have any experience at a workplace? And I said, no, I don't. Next. I couldn't get my foot in the door. And I'm off on a rabbit trail right here, okay? This has nothing to do with abstract data types. I eventually, in 2007, I got the military to pay to send me to a Java boot camp. And it was rigorous. It was 7 days long. We had to meet in the lab at 5 a.m. and we programmed all day long, all the way till 12 at night. Not kidding you. It was rigorous. And at the end of the week, after 7 days, they trained us in every topic that imaginable that was needed for the certification exam. And so the one I went to was in the Poconos up in Pennsylvania, New Jersey, somewhere, New York, I think. Anyways, I went to this, and at the end of the week, I took the exam, and I passed the certification exam from Sun Microsystems with a 72%. Passing was 65 for the certification. And I thought, man, I thought I really knew this. Because, I mean, I studied and crammed, and I'd been studying for 3 years at that point. So now Sun Microsystems was bought by Oracle. Oracle now is the certifying body for Java. There are a couple of other certifying bodies out there. I don't think CompTIA does Java certification. But you can do the Oracle certification. And Oracle has broke it out into 6 different tracks. You have a junior programmer, and then from there you can go on up, and so on and so forth. Anyways, after I got my certification, I applied for a new Java job. And they said, oh, I see you got a certification. I said, yeah, I just went and I just obtained it. Can we see it? I showed it to them, and they gave me a job. Yeah. And my first Java programming job started at $45 an hour. I'm just telling you because being a programmer is a great profession, but you have to be dedicated to do it, to study it. And studying it means that even to this day, I still have to break out my book and study the language and study aspects of it because they expect you to know your stuff. So, all right. Abstract data types. These are one of those questions that would show up on a certification exam. Basically, any class you create is called an abstract data type or program defined data type. These are things that are not built into the language. However, if you, with IntelliJ, if you control click onto the object class, you can see the source code for the object class. You can see how it was written and everything in it. Okay. That Siri just turned on. That was weird. Does y'all's phone never do that? Just Siri just turns on magically and wants to talk to you. All right. Let's go on here. We're almost done with the lecture. What time do we got? 4:30? All right, good. Remember, on your methods, these are some basic don'ts. Don't put a semicolon at the end of your method. The only time you do that is if it's an abstract method. Right? Abstract method. Or if it's an abstract method inside of an interface. Don't think your default constructor means the only one automatically supplied. Always go back and check your code because you never know if the code you're using that someone else has written or your code, if you put a default constructor in there and it has some side effects. Side effects is what I showed you earlier where you had the employee constructor and it was assigning a value. We call that a side effect. Okay. Don't think that the class's method must accept its own fields with values or return values to its own fields. Sometimes the return method is not going to return anything. Sometimes people put nulls in there to return. You always check it. Don't create class methods that have a parameter with the same identifier as the class field. All right, I'm guilty of that because I did that the other day in class for you all. You may have noticed that. I just automatically, for the pizza class, I did sauce, brings it into my mutator method, and I assigned it to this.sauce. It's not good practice to do that. My sauce as the parameter equals left assignment to this.sauce. All right. And that's it. All right. Right now, so we're going to create a new object, and I will wait till everyone is ready. IntelliJ and the JDK is installed in everyone's box, so you should be good to go. Stephen, I think you weren't here the other day when it was installed, so you may see a few extra configuration screens. They're pretty intuitive, so just kind of click through until you get to a stable spot. All right, we're going to create a new project. Create a new project. And it's frozen because it's thinking. There we go. We're going to use just a regular plain old Java object at the top left there. Create next. We're going to create a project from template. Use a command line app. When you have free time on your own, IntelliJ has a bunch of other templates that you can download and install. And remember, the best way to learn how to program is just play around with it and do things. Sometimes you can use the templates that are provided for free and do some really neat stuff. All right, so command line app, say next. We're going to call this our employee. Okay, click Finish. All right, as you can see, it automatically created, for me, a main class with a main method. It's kind of stubbed out here. And we're going to come over here to the source, go to your package name, and we're going to create a new Java class, and we're just going to call it employee. All right. We're going to start off just like the book, and we're going to create a private int employee number. And then we're going to create a private int. Let's create a department. Now you may have noticed that I set int to department, right? Let's go up here to the top. Now we're going to create a public static final int, and we're going to put it in all caps. And let's see, we're going to call this human resources equals 0. I'm going to copy that line, paste it again.
Sorry, there's nothing to repeat.
I had a Siri. What's a department we could put here? Business. All right. Business. And we'll change this value to 1. Public static final int. One more department. IT. Okay. Let's see. Let's do another private string, and we'll call this title. Private. Yeah, it could be, yeah, position title. Okay. Let's just leave it right there for right now. All right. Come back over here to your MDR, your package solutions, package name. I am tired, I'm sorry. Going to add a new class, and we're going to call this the employee name class. All right. We're going to create a private string first name, private string last name, private string middle initial, private string suffix, and I'm going to add one more at the top. Jessa made me think of something. Private string title. Okay. Now it's typical to want to add some ways to modify these, right? So we need some mutator methods. So I'm tempted to show you a cheat. You're winking at me, brother. All right. If you go up to code and you go to generate, you see that? And then you come down here to getter and setter. You click on that. You start with title and hit shift on your keyboard all the way to suffix and click OK. Look at that magic. You guys are like, oh, I love you. All right. The only reason I'm showing you this is because when you're programming, the idea of programming is to program more efficiently. Okay. And the setter and getter methods are very common. They follow the naming convention pattern of the names of your variables. And if you're using some of the Java APIs, they require you to follow that convention, the naming convention, especially if you're using some things, Java persistence API. It expects these beans to follow this pattern, and it's by convention. Okay, so that's why I use the generate. All right, we're going to do one more generate. Huh? No. No, put it right above your first method. And we're going to put a getter. Oh, I'm sorry. Yeah, constructor. So we're going to select all of those, right? And we're going to do that. All right. Now, if you're looking at this, you'll notice then that you can set these values two ways, right? How could we set them? We can set them through the constructor, and we can set them through the... Through what? We can set them through the setters, right? And we have only one way to see the values, and that's through the... There's only one way to get the values out of this class, and that's through the getters, because our get methods are public, right? And the class itself, the member variables are what? They're private. So this is called information hiding, right? Okay. Now, there's one other thing we're going to do. Go down to the end of the class, and I want you to go, go to the end of the class and go back up to your code on the menu, and we're going to generate one more thing, and this is an override method. Okay, we're going to override the toString method. toString, remember as I told you before, there are certain methods that are available automatically in Java because everything extends. Okay, everything extends. So I'm going to go in here and I'm going to generate the toString. I'm going to make sure I select everything up here. I'm going to click OK. And you see what it did for me? it generated a toString that uses string literals. And that's kind of nice because if I wanted to do a system out print line on my employee name class, it would actually print out what's in this toString. All right. Okay, so we're going to go back to the employee name. Guess what we're going to do? Private. Sorry, go back to the employee class. Okay. And we're going to say private line, I'm on line 12, employee name. I'm using the class that I just created. And I'm going to make it employee name, lowercase, and do that. Okay. So let's come back up here to our code. And this time, go to generate. I'm going to select getter and setter. And we're going to only select the get from employee object down to the employee name object. Y'all see that? Do not try to do getter and setter on public static void because you can't set a final. They're already set. Okay. So you're only going to select this bottom bit. Click OK. Come in here again. Go back up to generate. And this time we're going to create a constructor. We're going to select those. Click OK. And then we're going to come down here and we're going to do one more thing. Code, generate, toString. You guys following so far? Now, in the employee name class, the employee name class has an overridden toString method that will generate a string. And so here I'm saying append this with that. Append the string literal employee equals name plus to employee name object. When I do this, it's going to automatically call the toString method and pipe in that data into this concatenated string here. Okay? All right, so we've real quickly generated some code, right? It's nicely formatted. It looks pretty. It's got nice colors. I don't know what color sequence you guys are using, but all right. Got some yellows and pinks and oranges in here. All right, so let's go back to our main method. We're going to instantiate now two classes. And there's a couple of ways we could do this. We could say employee John. Is it okay to call you? All right. So I want to make sure. If it's not okay to pick on you, you tell me. And we're going to take the employee. And notice here that I cannot do just like that. Why can't I do that? IntelliJ is warning me, saying something. Why can't I just use just the standard constructor notation?
Because you need to input like employee number, department, string, employee name, and last name.
Yeah, absolutely. But more importantly, I created a constructor, right? As soon as I create a constructor, I overwrite the default constructor. And so now the signature for creating the employee has to include all of this data. I'm saying you can't create employee until you create this data, right? All right. So I'm going to do it with some new line spaces because it makes it easier to read. All right. So our first value in the employee is the, what was it again? employee number. All right, so this is employee 0. And the next value is the what? Department. And so I'm going to call employee, and you're going to be in the technology department, John. Okay? See what I did there? It's readable. I can understand what the value is, even though it's just a number. All right. So then the next value is what? The title? John, what do you want to be in information technology? You want to be the director. All right. Oh. I remember what this is called. The CIO. You're the big man. All right. So now we need to pass in something else for John. We need to give him the name, right?
Yes.
All right. We can do it like this. But guess what? I got a problem again. What do I have to do? The constructor for employee name overrides the default, right? So I got to come back in here again, and I have to specify. John, what is your title? Are you Dr. John? Dr. John? Okay, Dr. John. And my first variable in the employee name constructor is first name. Is your first name John or Johnny or Jonathan or
John.
just John? Okay. And I think the last name here is the next variable. What is, yep, it is. What is your last name, John?
Delos Reyes.
Delos Reyes. And you don't pronounce it the Chamorro way of Regis? Okay. All right. And so then we have a middle initial. What's your middle initial, John? T. If we don't have any constraints on this, so we could make it more, but for this, all right. Do you have a suffix, John? Are you a junior? All right. And so the way we handle that is just null. Okay. So here's our employee, and we could just do a system out print line on John, and because we've overridden the toString method in both employee and employee name, it should spit out the information in a pseudo-readable manner, right? And there it is. There's the information it spit out. It kind of put it in a JSON format. If you guys are familiar with JSON, you know what JSON is? Not the person. JavaScript object notation. All right, so if you've programmed in JavaScript, curly brackets and the name value pairs, right? So here's your name and value. All right, so this is one way we could have handled it. What's another more creative thing we could do here? We could do math.random. Uh-oh. What does it provide? A double. How do we handle that? Do y'all remember? Do y'all know yet? Huh? So math. It's not absolute. Where is it at? There's a way to convert. I think it's like floor or ceiling. Nope. Oh well, I can't use that one. But you can if you have the right amount of time. All right, what time have we got? 4:53. Let's add one more person. Who else would like to be a guinea pig today? You're already a guinea pig. Where's Omar at? All right, Omar. Equals new employee. And we got the same scenario, right? We can't make you 0 because he's already 0. So we'll do you as employee 1. And then the department is employee. You want to be information technology, business, human resources? Yeah. Okay, which one? All right. And then the title, what do you want to be in human resources? Director? That's the easy one, right? I don't know what human resource titles are either. All right. And then after that, we have new employee name. All right. So, what is your title? Do you want to have a title? Maybe Mr., Doctor, Mr. Okay. And then your name is Omar. Your last name is. Oops, wait a minute. I messed something up. First name. Did I? Oh, there you go. Gotta have a comma. All right. So, what is your last name again? A-L-I. And middle initial is C. And do you have a suffix? You're junior? Sweet. All right. So now we can do system out print line Omar. You guys understand what we've done so far? There you go. And there's all the information. Okay.
Sorry, but how's it not an error if the number is both number 1? So number,
How's it not an error?
if it's both 1.
Oh, because I made them both 1, didn't I? Because I don't have any rules in place to enforce that that piece of logic. If it was on a database, there'd be it'd throw up an error. Okay, so this is just some basic code, right? All right, we're like almost ready to go. It's actually past time. Now, a further step we can make to this code is we could actually have a new class and make it a specialized class, right? We could have some type of employee that extends from the employee class. And the way you would do that, come over here, and we would say, let's say I don't know, president. This is not really a good example, but extends from employee. All right, why is it complaining? Because there's no default constructor to employee. So the way you have to do that, I believe, there you go. You have to create the constructor to match, and then you call super, which is the super of president is employee. And then IntelliJ will generally, yeah. So then you could come in here and add in other private string identifiers that are particular to a president or to whatever object that is. All right, guys, that's all we have for today. And